Viewings, tutti devo scartare. கொஞ்சம் பிஓஎம் சிலபஸ் இருந்தா அப்படி காட்டாங்க போட்டு இருந்தாங்க.
Hello. Yes. Yeah, you are able to see the PowerPoint. Now you no you join. You click that join webinar. Okay. Waiting for me to share. Okay, then you will get it. Oh yeah, we'll get it. You'll get it in 2 or 3 minutes. You'll get it. Yeah, in 2 or 3 minutes you'll get it. That is coming. Buffering. Okay, okay. So that's what it will come. I think so. No, I'm about to share. Now what you're getting, check it. Okay, okay. Buffering. Uh, uh, Buffering. Okay, I'll check it out. Okay, okay. You take that screenshot, whatever it is coming, and post me to WhatsApp. I'll check it. In WhatsApp, you send it. I'll check it. Yeah, yeah. Because your name is not showing. No, then go to meeting. Go to meeting. ID is given. If you click that link, simply you can go. You got a mail. No, no. You click that. You fill that form. If you fill that webinar form, you will get a mail. Uh-huh. One I had put one link in WhatsApp now. You fill that form. If you fill that form and submit, you will get a link in your mail ID. Go to your mail ID and join webinar. You will get it. Uh, uh, Thank you for registering. Join webinar. If not, yeah. If not, you will get a webinar ID at the end also. So that's what I'm also not getting exactly. Yeah. Okay, I'll tell you the webinar ID if you don't get it. 559. Yeah. Uh, yeah. 559 162 707. Check whether it is connecting. Yeah, you have joined. Yeah, I am able to see your name. Yeah. Your name is displayed. I am able to see your name. Opening. It will open in that exact 6 o'clock. Exactly at 6 o'clock it will open. So I'll share this webinar ID also. Okay. Okay, you type some questions in this one. Type questions in the Q&A section. Q&A will be the left side. Okay, left side you will get left. That only. No, anything you put. Yeah, HLOOSIR, right? Yeah, then you have joined. I'll send. Yeah. I think setting is like that. And that's what I'll put it. You don't worry. Thank you.
வருதம்மா
Go ahead.
யார்
Okay. Yeah, good evening to one and all. Are you all able to hear me? Good evening to one and all. I hope you all are able to hear me. Please check your audio settings. If you're unable to hear, if you're able to hear me, please type in the question and answer session. A box at the left side you will be having. So type in that such that I can understand you are able to hear me. Yes. Is the first page of the slide is visible to all? The presentation is on optical communication, Unit 5, ultra high capacity networks. Is the presentation first slide? Can you able to see the screen which I am sharing? Yeah, someone has replied me that they can hear me. Right, very good. So till now there are some about 25 participants for this session. So one by one it's increasing. So let me wait for another 2 or 3 minutes. If you're having any, yeah, yes, you're not getting, but your name is showing. Yeah, you get. I can. Yes, give yes. Yes, yes, give yes. But I can see, but I can have in view on you. You are there. You are there in webinar. No, that is for downloading. You are able to see this screen or not? The same. You're not able to see. Okay. Um, you're not able to see the dashboard. Hmm. I am not doing anything. Just the first slide I have showed. Slide is not okay. I'll check it out. Now, now you got it. Now you got it. First show, first slide. Okay, okay. Type everything in the questions. Thank you. Hello. Yes, you're able to see. Both. If somebody is not getting using that join webinar in mail, you can use this ID. Okay. So I think probably everyone is able to see the first slide. If yes, please type in the question and answer checkbox such that I can understand you're able to view and you're able to hear me in this session. Hi everyone, good evening to one and all. Hope you all are fine during this COVID-19 period. I can understand that you can see me, right? So I'll stop the web camera and I would like to start the session. So waiting for another 2 or 3 minutes. Still there are 35 to 40 participants. And hope you all are fine. If you have any doubts or any queries, you can type in the question and answer session. Fine. So this is an session that we are going to see on ultra high capacity networks, where we are going to use optical systems in that. There are some questions being raised. I'll check it one by one and I will start the session. Yes, okay. Okay. I think Sainath has joined. He was first to join. Deepak has joined. Raised for a second. Yes. Harish is able to hear. Ranjan is able to hear, right? Abraham is able to hear. Nitya is able to hear. Purna, the slide is visible, sir. Okay, right? Okay. Okay. So I understand that everyone is able to hear me and you are able to see the slide which is being shared. So good evening to one and all again. So this is Dinesh Kumar, going to take optical communication unit 5, ultra high capacity networks. So the ultra high capacity networks is an advancement of the optical fiber communication system that provides higher bandwidth and higher accessibility towards enormous accommodation of channels. At least the ultra high capacity networks will use 25 terahertz of bandwidth for a higher and efficient transmission of your data signals that are being transmitted over optics. So this technology uses denser WDM concept. So I think in the lecture made by Dr. Archana Madam, the topic on wavelength division multiplexing. So we'll be using a denser systems where it can accommodate more number of channels onto a single fiber cable. So this is such a type of application where we can accommodate more number of bands into a single fiber for efficient and longer transmission of data signals. So this is your second point, denser WDM technology being used. So this uses ultra fast optical TDM. The bitrate will be higher compared to as the other fibers of optical that you are using. So the time division multiplexing. So wavelength division as well as time division is being done in this ultra high capacity network. So then this increases the capacity of long haul or the long distance transmissions over a while. And With the existing data rate, we cannot achieve an appropriate longer distances of communication. So this ultra high capacity networks provides us a platform and provides us to increase our datas from 1 Mbps to 10 Gbps or even 100 Gbps or even 1000 Gbps depending upon the PON that we use. So these are very much in attractive with the local area networking as well as the metropolitan area networkings. So this supports coherent ultra denser UD stands for ultra denser wavelength division multiplexing of PONs, so passive optical networks. So this PONs will be having an data rate in the form of terabits. So probably it starts with GPONs, XGPONs, and it goes on. So the data rates and the channels vary depending upon the application. So this ultra high capacity networks also support crosstalk mitigation. So I think everyone are familiar with the crosstalk mitigation that we had experienced in our childhood days. Okay, when we ring up a phone, crosstalks will occur. So somebody will be dialing one number and it will sometimes, not every time, sometimes it will go to a wronger number. Somebody else will pick up the phone and they will answer the calls. So crosstalks will occur in those days. So those are all being minimized. Those are all being removed off using this OFCs, this type of OFCs particularly. And these are applicable for a real-time coherent PONs. Realistically, we can translate all this optical signals using PON being implemented in that. So these are used in field trial basis systems. These are always flexible in nature, and particularly when we use PICs, which we call it as photonic integrated circuits. When we integrate that in PONs, they give high amount of data rate. So the name itself terms that ultra high capacity is that carrying more amount of data and network inside the same optical fiber structure. So you can see the diagrammatic representation of the ultra high capacity networks. So adding extra flexibility and global control over the system. So this context, we have data servers. This blue, you are, I think you all are able to see this diagram. So where we have binary context, we have three data servers. So next to that, we have an antenna structure. Okay, so this is your data server. From there, we get the data through the antenna. Through the radio frequency overlay, we have the OTDRs connected to the CE. C is your core equipment. We have the GPONs, we have the XGPONs. So this GPONs has data rates of 10 Gbps. This XGPONs has 100 Gbps of data rate. So this yellow color, whichever is present, is your connection of the optical fiber. Okay. So we have the time-based wavelength division multiplexing one for different systems, OLT1, OLT2, online terminal 1, online terminal 2, till the number of available systems n-1. We have WDM based systems which are WM wavelength multiplexing connected to your core equipment. So this core equipment in turn acts as your transceiver from where we get this signals. Obviously from home, obviously from repeaters, obviously from automated industries, obviously from any base stations. You can see the base station symbol. We have the offices, we have larger buildings, all are interconnected through this system. So the yellow color lines which are being drawn is all your optical fiber cables which are meant for carrying higher capacity of data. Yeah, I can see that in my screen some of uh, them are not attentive, not attentive. It blinks me, it shows me not attentive. Okay, I'll leave it up to them. They are in the meeting, but as usual, they're not attentive. Yeah. So kindly check the settings uh, such that you can attend it appropriately, or you can type me in the question answers if you have any troublesome. Okay, back to this slide. So this XG-PON, which was given by a system, it uses 1260 nanometer to 1280 nanometers. GPON uses 1300 nanometer to 1320 nanometer, whereas GPON DS uses that spectrum, uses 1480 to 1500 nanometer. TWDM uses 1530 to 1540 nanometer, and the radio frequency video uses 1560 nanometer. XGPON in DS uses 1580 nanometer, whereas TWDM PON uses 1600 nanometer wavelength, whereas the WDM of having different visible spectrum uses 1620 nanometer. So the challenges are for this system using a good tunable lasers and receivers appropriately. So if you use an appropriate receiver and a laser, we will get a good ultra high capacity system. Going to the next slide. So there are so much of future opportunities for accessing this ultra high capacity networks in OFCs. So you can see the same label of Q band, sorry, O band, E band, S band, C band, L band, U band of the frequency spectrum. You can see the different systems used in GPON, XGPON, water peak, later fibers, the threats in the GPON, the opportunities which are being highlighted in green in elliptical shaped structures. So those are the opportunities that we need to use for improving the system. And the threats are obviously in red color, which is being mentioned. You can see that they are being highlighted in red color. The frequency, sorry, the band between the 1500 in S band to 1625 in nearly in U band. These are the threats. So which way we can explore them and we can use it for maximum transmission of your data. So this shows your spectrum of the opticals used in passive optical network in ultra high capacity. So the future will target on higher data rate per user. Every individual need to have a higher data rate with maximum spectral efficiency and having a more number of users per optical denser network. So this is our target. Flexibility in network and reaching every corners of the geographical area. So here you can see at the bottom that the green color shows the number of channels which is being used in A axis. A has been cut out, so sorry for that. In B we have the spectral efficiency. In C we have the bitrate per channel. So all these three has to be considered for increasing capacity in this network for increasing our data rate. So these are the essential which is being given now, and what are its future is being listed out here. So what is present is that we have a low cost system which is highly tunable with a controlled wavelength having 10 gigabits per second as your data rate, which is currently available with the optical fibers. So what is our aim, or what is our futuristic view, is that in order to increase the data rate in this, we need to have a wider tunability which has a minimized tolerance loss, and we need to have greater than 10 gigabits per second, which is your data rate, to be required for satisfying high spectral density. So for this, the systems proposed are GPON, NGPON, and XGPON, where they can be collaborated with the DW, DM with coherency and advanced modulation formats in the core equipment. I'll show this what are these advanced modulation formats used for increasing the ultra capacity. So there are two methods of time division multiplexing that is used in this system, which is your bit interleaved TDM and time slotted TDM. So depending upon the bits, we can access our system, dividing the data bits into small formats and then sending it with a higher data rates. Or we can use the time slotted, depending upon the time, whatever we get, that we can divide and we can send it. So this structure shows bit interleaved optical TDM. So we have 10 gigabits per second per pulse streams which are being generated, given to an optical splitter. We'll be using four data sources, four 10 gigabyte sources, which splits it equally, transmits it. Again, it's being summed up at a point where we may get some fiber delay losses or fiber delays that can be minimized by using an appropriate post amplifier or a pre-amplifier, where we can use our doped fiber amplifier of RBM type. So EDFAs. EDFAs are helpful here. So where we can see that the pulse signals of ABCD, which are given at 4 modulators, are having peaker amplitudes. You can see that A rises, B rises, C is risen at a smaller peak, D at a smaller peak, and it goes on, repeats itself. So that can be recovered at your receiver side at your clock recovery at 10 gigahertz, and the appropriate ABCD modulators which are used at source can be demodulated easily. So this gives an ultra fast point-to-point transmission system. So coming to the next slide is that the ultra high capacity. How can we increase this ultra high capacity which is in existing? So there are two methods that we can use to increase our capacity is by widening the spectral available. Okay, what are the spectrum is available? Increase it from available lambda to another lambda, we get the broadening of spectrum. So to widen the spectral bandwidth, use EDFAs, erbium doped fiber amplifiers, to amplify. So which are operating from 30 to 80 nanometer. So we'll get an enhanced spectrum. Okay. So second thing is that increasing the capacity of WDM. So if we increase the capacity of WDM, obviously our spectral efficiency of the WDM signal will increase. So this is another method. So another thing is that if I have or if I minimize the non-linear effects, also I can improve the efficiency. So how do I avoid this non-linear effects? Is that by using a data rate of 20 gigabits per second for every individuals. If these are being implemented, the existing optical fiber which uses any capacity network will get higher spectral efficiency and larger data rate. So the examples are using two examples I have given you, which are being in existence. See, for a 600-kilometer link, the total transmission distance with an operating bitrate of 1 minus TB, sorry, it's 1, not 1 minus 1 TB by seconds. That's what 1 bitrate per, sorry, it's 1 for sending off your one data rate at one time interval per second is our data rate over 600-kilometer link. We can use an 50 channel WDM system. The second is that we can use an 120-kilometer link with a data rate of 2.6 TB per second, which operates at 132 channel WDM system. If we use this type of systems, we can increase our capacity. So this is what the illustration from these two examples are. So 1 bit per second and 2.6 bit per second. Okay. So in the next, we'll be seeing the applications of this ultra high capacity networks. So you can see that the systems which has higher spectral efficiency, which is flexible, which has high performance technology, which is realistic in nature, which has good optimization of the networks being used, are being used in WANs, wide area networking. Connecting that wide area networking, we can use it for the connection to our homes, home automations, broadcasters, base stations. You can see the yellow color lines wherever is of OFCs that are connected to the ring structure. You can see a ring type of structure of elliptical shaped. So which is red, green, violet, and lightish blue, I think, right? So those are the electrical connections. So wherever we have yellow connections, purely those are your optical fiber cables operating at this. So when we see that the red color line which all connects in a ring shaped structure uses QPSK modulation. So in the previous slide I had told you about the modulator being used. See here, DWDM plus coherent plus advanced modulation formats. So in this we'll be using an appropriate modulation depending upon our need and application. You can use it for data centrics, connection between the server and the applicants at homes, or using of mobile backhauls. So the mobile backhauls is that our base stations will be interconnected with each other with the help of optical fiber cables. Okay, so all the base stations will be connected to each other with OFCs. So this is an application one. So another application is that low cost, high tunable OLTs, online systems, which has OFC cables interconnected to each other for higher data transmission. You can say that the red color indicates the modulation system of QPSK, the pinkish 8 QAM, the light pinkish, we don't have light pinkish, yeah, light pinkish is 8 QAM, yellow is 8 QPSK, green is QPSK, blue is QPSK. So depending upon the need, we can interconnect them. We'll interconnect with also the broadcasters. We can interconnect with even mobiles, backhaul, data servers, offices, different home appliances. Wherever we want to connect our system for a high-end transmission of data and communication, we can connect. Right? So these have a low-cost tunable system. These will have full support of PICs. So PICs is that photonic integrated circuits. So, so this is taken as a reference from our optical communication Kaiser. So as usual, if you have any queries, you can email me to my mail ID. Thank you. I'll take another 5 or 10 minutes to have a discussion with you all. So I'll open my questionnaire box. If you have any doubts, you can raise your hands. You can raise your hands and type whatever you want to ask related to this presentation. So some there are 45, okay, 46 participants available. You can put your questions. I'll see one by one and I'll address you. Yeah, sign up still. Hello, sir. Right? No questions from your side. Sai Sindhu, yes. You are not. Oh, okay. I think I had, sir, only first slide is visible. You're not visible. Okay, I had turned off my webcam, so you cannot see me. If you want to see me at the end, I'll turn on the webcam. Okay. So this. Okay. Deepak. Okay. Hello, sir. Right. Suhel. So totally how many brand we will have in optical spectrum? Okay, so to answer question of Suhail, Suhail, it depends upon the application. We have some 7 or 8 as I'll show you this slide again in optical. So the frequency band spectrum. Okay, I'll go back to that. Okay. See that we have O band, we have E band, we have S band, we have C band, we have L band, and we have U band. So all 1, 2, 3, 4, 5, 6. 6 bands are used and unused also. Some some bands are being used, some bands are unused. So this is where we need to explore and increase our data rate. Okay, by maintaining a specific God band. I think hope Suhel would have got the answer for his question. Right? You can refer this slide. The number of bands available in optics is all this spectrum in optical access after implementing our passive optical network. So coming to next, yes, you are able to hear Pavan. Next question by Harish. Yes. Ranjan. Okay, yes. Pavan. Sir, what is WDM? Wavelength division multiplexing. So normally we do uh, 3 different types of multiplexings. One is our time division. With respect to time, we divide our slots. Another is with respect to frequency, we divide our slots. Third one is the code division. So with respect to a spectral of codes which are used as pseudo noise sequences, we call it as PN sequences. With respect to that, we do uh, division of our data. So similarly, we have in optics specifically, depending upon wavelength, we can send our signals. So that is what wavelength division, dividing the available wavelength into smaller parts and sending our data onto that as we do multiplexing and demultiplexing in digital drawings. Okay, so I hope this question is and has been answered. Wavelength wavelength division multiplexing, right? WDM. The lecture for this WDM was given by Dr. Archana Madam. You can see the link which I posted in Google Hangouts. You can see that. You can understand WDM. Okay. So Raghuram has a question, I think so, right? Yes, I is able to hear. Okay. Yeah, yes, sir, we can hear you, right? Fine. No, I have, yes, sir, I can hear and visible, sir, right? Okay. Harish, hello, sir, right? Okay. So apart from this, any other questions? I'll take another 5 or 10 minutes to address your questions or address your queries. Please put in. So I would like to share some information is that circular from UGC and MHRD has come. I think probably most of you have received the circulars. So we are awaiting for instructions or information from our university for further processing. So hope so you will also get those informations at the earliest if it is being processed regarding the examinations, regarding the timetable, regarding the opening of classes, and so on. So keep in touch with me in the WhatsApp group. Any doubts or any queries or any issues that you face, you can post me in that on a regular basis. Then and there itself, whatever extent possible, I will address you all. And as per instructions, I am liable to conduct a test for this um, optical fiber communication, as I'll be considering this marks for your internals. I'm not sure about the probability of conducting a second internal physically. So I have a plan. So I'll discuss with the CR of both the classes. I think probably A section and C section for optical communication subject particularly. I'm talking about the subject optical communication alone for awarding of internal marks for this subject for both A section and C section. So I have a plan. I'll discuss with both of the CRs and how possible extent it can be done. But test is to be given. So I'm thinking of an idea. So hope it comes well suited. And then somebody has asked the difference between frequency division multiplexing and wavelength division multiplexing. So the basic concept is that FDM, TDM, and CDMA are applicable only for electrical type of signal. So whereas when we transfer our data on optics, we need to use only WDM. Yes, August, is that true? Yeah, this is a lengthier question. Just I'll see. As per we have information that only final year exams will be conducted. No, that's what the answer will asked by Sai Vardhan, I think so. Yeah, Sai Vardhan. Only final year exams will be conducted. No, for everyone it will be conducted since they are to the final year students are going to leave this university, in all the cases, their exams will be conducted first. Then the students, those are going for in immediate semesters. That's what, from first year to second year to third year, and third year to final year. For them, exams conduction will be at the time of reopening or at an postponed time of reopening. So that is what the circular indicates. I hope I would have answered this. But exams will be there for all. Don't worry. It's just a recommendation to the universities and all the higher education institutions that they had given. Exams will be there probably that they are discussing, and we'll get a notification soon. Difference between FDM and WDM, right? We cannot differentiate it on a parallel base. FDM, TDM, and CDM are purely on electrical signal based, whereas WDM is on wavelength based, that is in optics alone. So I've done question. Then any other questions? Regarding the internals, so regarding the internals is that an idea I have thought I'll discuss with CRs of both the classes for optical communication, and we'll come out with an appropriate solution for that. So in regard to that, I need all of your cooperation. So for conducting this internals successfully. Then when college will reopen, Deepak is asking. Deepak, that's what they are thinking of. You'll get a circular. Whenever the circular comes, I'll post you in WhatsApp group. I'll check for other questions. Anything else? Sai is asking the last date for payment of examination fees. The examination last date fees is not yet given. They will decide it only on the reopening date. Let them decide and give us. Just enroll and keep. Register yourself. If you're having paid, or else wait for the last date. Kamal, frequency wave and codes. What is that? I'm unable to understand the question. Users. Where is the question? Lockdown period is extended to May 17th. No, not sure. Still, here it hasn't been announced. Probably the chief minister is discussing with the appropriate team. On ODN application, these are what the applications of. These are the applications. I'll share you another slide. I forgot to show that. Just a minute. This is your passive optical network. How the structure is, what does it uses, is all given it here. I'll share this presentation also. This is apart from your away from your syllabus. Fonts, active fonts and passive. Obviously, we'll be using fonts in most of the cases. Okay, it uses is that it is being used in high data rate, so we can split the same signals for up to 128 subscribers at the same time in GPONs, and up to 32,768 for EPONs extendable, which are having higher data rates. So this is used in standard TDMs. If you use standard TDMs, SDH and SONETs. So any other questions? TDM based, WDM based, advantages, maintaining good quality of service. So I'll share you this. Do not worry. So any other questions? Okay, with this, I would like to end the session. Hope you all would have understood this ultra high capacity networks. See you in another session. Thank you. Is it fine, Sai Sindhu? I hope you would have seen me, right? Thank you. Be in touch. Stay home, stay safe during this period.